Welcome to Cloud on Air, live webinars from Google Cloud. We're hosting webinars every Tuesday. My name is Melody Meckfessel, and today we're going to be talking about the secrets of top-performing DevOps teams. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's get started. Thank you so much for being here, Jez. I'm so excited to spend this time today learning about your research in high-performing DevOps teams and to share some examples from Google's experience.
Thanks very much for having me. It's a pleasure and an honor to be here.
Great. So let's dive right in. We're going to talk a little bit about defining DevOps to orient us all around what's included in it. We're going to dig into some of the fascinating research from Dora around DevOps performance. We're also going to talk about some findings and how we balance speed with stability in terms of software development. Dig into how we can all improve as a community, as both individuals, teams, and a community, and then finish up talking a little bit about the role that open source is playing in DevOps.
So what is DevOps? There's no agreed definition of DevOps. I'm sure you have a different one from me. Somehow mine has made it onto the slide. So I like to think of DevOps in terms of the goals we're trying to achieve and the people who are trying to achieve those goals. So I like to talk about a community of practice dedicated to building, evolving, and operating rapidly changing, secure, resilient systems at scale. So that's what we're trying to do. It's hard. We haven't worked it out yet. We're all improving all the time. There's three key areas that I think we need to think about and that our research covers and that we're going to talk about today. Number one is organizational culture. We're spending a lot of time talking about that. Technical practices, and then finally, management practices, which are also important if you're going to achieve the kind of things we talk about.
So, as developers and operators, we're really focused on how do we take that idea and get it out to the user community so that they can get value out of it. And I think it's interesting to think about where we are in terms of how DevOps is enabling us to do that. So we have the idea of taking that idea and understanding what the requirements are of the business, like writing down what features do we think we need to actually go, fingers on the keyboard, develop code around. And there used to be this wall, right, of throwing requirements back and forth between the business and development. Well, Agile really helped us solve that wall and break it down. But as we both know, there's another wall that has existed between development and operations. So once the code is done, it needs to be operated out in production. And there's a wall that exists of sort of throwing the release over, so to speak. DevOps is helping us break down that wall and help increase the velocity and the practices around moving from development, writing, building, and testing code into operating at scale from production, with the intent that as we increase that cycle time and improve the reliability, we're delivering better quality results out to the market and out to the users. So the research, again, fascinating to see the impact of DevOps on overall performance. So software delivery performance, there's some information that comes out around the difference between high performers and elite performers. And we see from your research that elite performers are 1.53 times more likely to exceed their business outcomes. And those outcomes are measured by productivity, they're measured by profitability, by market share, real concrete positive measures in terms of getting the software out to the end users and the market. It's fascinating to see that impact.
Yeah, absolutely. And I think that has been one of the big outcomes from our research for the last few years, seeing that it has a business impact. Also, just having a way to measure DevOps performance. So Google, obviously very metrics focused. We found a valid and reliable way to measure software delivery performance, which helps us also understand how to change performance as well. We can do statistical research on the factors that improve performance. And again, we'll talk about that today. So how do we measure performance? Two kinds of measures. Measures of throughput, how fast we're going. So deploy frequency, how frequently we deploy. And then lead time for changes, how fast can we go from version control, code in version control to production. Then two stability measures. So time to restore service if there's an incident or an outage, or service degradation, how quickly can we restore service? And then change fail rate is kind of a measure of the quality of our release process. When you push out a change, what percentage of the time do we need to roll forward or roll back and remediate? And if there's kind of one thing to take away from this, it's high performers are not trading off speed and stability. We kind of have this idea that going faster means breaking things. That's not the case. Consistently over 5 years, we find that high performers are better at throughput and stability, and low performers are worse at throughput and stability.
And it's interesting when you think about it, you have to come back and fix the problem.
Right.
Right? So you want to decrease the amount of time for that mean time to resolve.
Right. Exactly. I mean, failure is inevitable. We're operating complex systems. You've got to take that into consideration.
Absolutely.
So here's what we found this year. Every year we do cluster analysis, and we find groups within our data that behave in similar ways. This year we found 4 groups. A low-performing group that's releasing pretty infrequently, between once a week and once a month. Their lead time for changes is measured in months. It takes them a long time to restore service as well, and their change fail rate is between 46 and 60%. So that's at the bottom end. Again, doing badly at all of those measures. And then up at the top end, we have these elite performers. That's 7% of our total. They're deploying on demand, so they have multiple deployments per day. It takes them less than an hour to get changes from version control to production. If they need to remediate because there's a problem, they can do that in less than an hour, and we think that's because they're able to use their normal process for remediation as well. There's no special emergency process where you skip a bunch of the testing. You can just use your regular process, and their change fail rates are really low. They have a really high quality release process. This year, we extended our measure of performance to also include availability. So availability, obviously, your users can access your service, and also you can make promises about the availability of your systems so that your users and your customers can rely on them. Again, we find that people are not making trade-offs. They're not going faster and availability is going down. In fact, quite the opposite. Elite performers, in terms of software delivery performance, are 3.55 times more likely to have strong availability practices. So these things all go together.
So let's talk a little bit about that balancing of speed with stability, because we know that users' expectations around availability are increasing. So as an end user, if I go to use a particular app or system, I expect it to be up. I expect it to be available. So I just wanted to start by grounding in the fact that us as a DevOps community, as software teams, make decisions around availability. And I think we need to remember that perfection is unrealistic. As far as I know, keep me honest here, no human has ever created a perfectly reliable system. And if we look out to nature, we see the same thing. Competitive pressures, evolution of systems, perfect reliability is not the best target. So let's talk a little bit about why. And I think it comes back to perfection can be wasteful. So your users of your application, your system, have many other dependencies. This is the reality with infrastructure and cloud infrastructure. And your users experience reliability as all of those dependencies together, of which your service is one. So it's important to come back to thinking about the expectations of your users and the overall expectation of those dependencies and your understanding of them. They may not notice, I'm going to give an example here in a second, they may not notice the difference in adding 2 nines to your availability, but they're probably going to notice the cost. So what is the goal around setting these availability and reliability targets? It's really to make our users happy. They expect this level of availability. And we as DevOps teams have to balance the features that we're giving to the users with their expectations of reliability. So we want to set those reliability targets to be in line with the other dependencies that the users have accepted and to understand that. Insufficient reliability, it makes unhappy users, right? Our goal is to make our users happy. But if we have excessive reliability, we're going to waste opportunities to launch features and to release at high velocity, as Jez mentioned. So think about the trade-off that's being made there. And there's a bunch of factors that can go into this. Users have different expectations around service levels that are set. There's things that we can consider around expectations for paid services versus free services. What's happening with competitors in this market? What are they setting their reliability targets? And always to come back to the cost side of this. There's a human cost, effort, and time to hit certain reliability targets and availability targets. So we need to consider that in the decisions that we make as DevOps teams. And at Google, we found that this objective metric called an error budget helps balance availability with velocity. So you take, 100%, you set your availability target, and you have your error budget so that product management, developers, and SRE are all working off the same metric. And there's flexibility, as we'll see. If you have error budget remaining, maybe you're going to take more risks on the release side, having that understanding of how your service is operating. So this is an example. You can see here, and I just want to call out the difference. If you have an availability target of 3 nines, you have around, you can see per year, per quarter, 30 days in this slide. But you can see you have about 2.16 hours of allowed unavailability, right? So that's downtime. That's time that your users are not going to be able to use your application. If you wanted to target 5 nines, which for some systems that may be correct, you've only got a minute 0.30. I mean, that's
terrifying.
It's terrifying. So we really want to come back to, you can set this metric, make sure it's in line with the dependencies, make sure it's in line with the user expectations, and know what the trade-offs are going to be, because that level of service may be required, but it comes at a cost. So what are the benefits of creating these error budgets? We're going to talk about culture in a little bit, but creating common incentives and a shared fate or a shared responsibility around uptime is so critical. And we've found at Google that between developers and SREs, this is the way that we balance innovation and reliability. And the other aspect of this that I find really important is that the developers become self-policing. So the operators, that wall between development and operations that we talked about, just really break this down where everyone has a common goal around uptime, and developers know where those trade-offs can be made, maybe where we could take more risks around feature velocity. But everyone's on the same page, everyone's oriented around that metric. And I have examples within my development team where we're all looking at the error budget and seeing where we stand for the quarter and making sure that we're falling within our availability targets. It's super important.
Okay, so we talked a bit about what's important to measure and how you can think about those measurements and use them to drive changes in behavior. We're going to talk a bit about how you actually get better at this stuff. What are the things that you can do if you're not doing so well in terms of performance that can shift you to the left in this case? And shifting left is going to be a big theme. So 3 things we're going to talk about and that we've measured over the last 5 years: technical practices, culture, and management. So obviously, a lot of the focus of DevOps is on automation. You're going to talk about some of the tools that you use at Google. Automation is obviously very important. And in our data this year, we find that elite performers have higher levels of automation, lower levels of manual work. This is interesting. This is something you can only measure through surveys. You can't look at system data and find out how much manual work is being done. You can only find out by asking people. We see that low performers are doing much more manual work when they're doing configuration management, deployments, testing, change approval process than our elite performers are doing. And that should be no surprise. One of the things that elite performers do is find ways to automate things that are repetitive, that are algorithmic. But these numbers are not zero. It's important to bear in mind that there will always be manual work. There's always going to be things that you're going to have to do. Continuous delivery, there's this misconception that some people have that it's about automating everything, that we're going to get rid of testers, for example. That's absolutely not the case. There's still manual work to be done, exploratory testing, usability testing. That's critically important. The other thing to point out about this is that you can't just take complex, painful processes and automate them. You have to simplify. So there's a simplification piece in terms of architecture, processes, that has to go hand in hand with automation.
I think it's you found here that we talk about toil a lot, and there's many dimensions of toil, but you can clearly see how automation is coming into play from low performers to elite performers to really make time to address the toil and to factor those improvements back into the workflow.
Yeah, and actually it's not in the presentation, but in the report, we look at the amount of time that people are spending on new feature development versus non-value add work like fixing problems, and we find that elite performers, 50% of their time is spent on value add work versus toil. So it's an interesting reflection of something that you observed at Google.
Right.
So how do you actually improve your performance from a technical perspective? Well, over the 5 years that we've been doing this, we found a whole bunch of different practices. Obviously, there's the classic continuous delivery practices of good configuration management and version control, continuous integration, automation around the test and deploy process. This year, we also looked at continuous testing, which is we're not just going to automate some of our testing, we're also going to build testing work into the software delivery lifecycle, have testers working alongside developers, test in process, monitoring and observability. Turns out those things are important. Obviously, you spend a lot of time thinking about that and doing that at Google. So that has a big impact on your ability to deliver with speed and stability. Building database management and security into the delivery process, again, shifting left on that stuff, and we'll talk about security in just a little bit. Those things together all impact software delivery performance positively and availability. Interestingly, they also positively impact culture. So we'll talk about culture in a bit, but how do you change culture? Well, you change it by changing how people work and how they behave.
Right.
Technical practices are a big part of that. Also want to point out these technical practices reduce deployment pain, and they also reduce team burnout. So obviously we want to avoid teams that are working crazy hours and feeling a lot of stress. That's bad for the humans, and that results in bad outcomes. These practices can reduce burnout as well.
Yeah, it's so important. So I wanted to share an example of that I think demonstrates a lot of the principles that and findings that you found. So Google invests significantly in code review. You can see a stat here, about 20,000 code reviews a day. We do this as a way to invest in education among the developers and operators that are writing code and trying to get those features out to our end users. But it's a significant investment in quality, right? We want quality code because we want to find the issues before we're further along in the deployment pipeline. And we want to find it definitely before it gets out to the end users, as much as we possibly can. So we've invested a lot in automation around code reviews. And the intention behind this is to have that automation free up the human's time to focus on the content and the quality and the improvements that can be made to the code. So we've incorporated things we call them robo reviews, robot code reviews, where we're looking for checks and tests and analyzers that can do things like enforce the style and formatting, because we know that increases readability and it makes it easier for the humans to interact with the code. Compiler-based analyzers to look for problematic patterns in the code so that we can prompt the developers and operators to look at that and take action based on it. Custom analyzers, we've created an internal community and ecosystem around custom analyzers that different engineering teams can adopt, and then if those are valuable, other teams can adopt them. So you're creating a community around these types of analysis. And then finally, building all of this, build and test into the CI system so that the code, we're running the test and we're catching issues in the code, and we're surfacing those in the code reviews as fast as we possibly can to catch it before it incurs the cost in the rest of the development workflow.
And I find it, really fascinating that you've invested so much effort into making the code review process smooth and easy. One of the things we talk about is working in small batches, developers being able to make small changes and push them in. And that is critical to have a code review process that is simple and smooth so that you can do that very frequently.
Yeah, I think there's definitely some interesting points there around taking risk and knowing that the automation is there, and then doing those small batches to be able to release as frequently as the teams possibly can. Yeah. So beyond code review, we want to build automation into the entire workflow. And it's great because developers and operators just continue to raise the bar on the level of automation. Definitely shows up in the elite performers and how they're spending their time. So if we start and we just go around the circle, we have cloud source repositories to help with version control, to present search, and different levels of insight into the code. So fingers on the keyboard writing code. Then we go with 2, 3, and 4 into the build, test, and deploy pipeline. So cloud build, we'll talk about security in a second, but the ability to build and test your application, and then using container registry, be able to then take it into Spinnaker, an open source deployment system, to release your code, high quality code, to the underlying platform, whether that's compute engine, Kubernetes engine, or app engine. But we can't stop there, right? So we have systems like Stackdriver that are monitoring, alerting, and logging to look for if we deployed something and there's an increased rate of errors, we're going to make sure we take a look, the operators can take a look at that and take action. And we actually have ways to then bring that back to code that exists in the repo. And then we go around again to fix the issue. So I think this cycle of continuous improvement with insights and then building that automation into the workflow really makes the developers and operators feel like these systems have their back. And then they're going to focus on the high value content related tasks that they need to do with the code and with the service.
And I love the fact you've got all these feedback loops going back to developers from all the different parts of the delivery pipeline here. That's really great.
Great.
So, security, finally, we made it.
We all have to care about it.
Yeah, I mean, this is something that I often say. You can't build stuff that doesn't have security and performance and have the magic DevOps pixies come after dev complete and wave their magic wand and fix the security and performance and availability. You have to build it in. So we find in our research, building security into the software delivery process, shifting left, improves not just software delivery performance, but also the quality of your security. So it improves both outcomes. When we gather the data this year, we find that elite performers are building security in, and they can do security reviews and remediate any problems they find in the space of days, whereas low performers are taking weeks, not just to conduct security reviews, but also to fix the problems that they find when they're doing them. So that's a real problem and a real constraint for many people in their delivery process. So what do we want to do? We want to build security in by running security tests as part of the deployment pipeline, as you've talked about, and I think you're going to talk about a bit more, and making it easy for developers to consume libraries that are known to be good. Obviously, if there's a CVE discovered in a library, you want to be able to get a fixed version of that and get that out into production as quickly as you possibly can. Another instance where time to restore service is really important. Lead times are really important. Make sure that your tool chains and your processes help developers build security in as well.
Yeah, the timeliness of security reviews, the ability for the developers to react, and then where we go next is building that automation in to help them from the beginning. So just some examples. Again, Jez talked about shifting left. We're writing code, but then we need to build it, and as part of that build, the code may be changed by multiple people on the team, multiple dependencies. So we've built vulnerability scanning into Cloud Build to detect those issues so that we know ahead of time before we get further down in the deployment pipeline where there's a problem. We're also building in policy creation and enforcement to give the power and control to the developers and operators and to software teams to be able to enforce certain policies like binary authorization. So if you look at just these two pieces, and I think these are really the beginning, we're getting to the point where we have something that's trusted that we can then deploy and really understand that this is a high quality release that's going out. Because what we want to know is if there's something that's untrusted, if there is a security vulnerability, and empower the DevOps teams to act on that before they get further in the pipeline. So we're tightening that loop around security to address those issues long before it makes it to the end users.
Yeah, and I know that, security is so critical for Google. You have systems like email that state actors are trying to interfere with. So this is a great example of how actually these practices really help with improving security. Mm-hmm. So management practices. So management's important as well, obviously. Over the years, we found that lean approaches to product management are really critical at improving performance and culture and those organizational outcomes we talked about, profitability, market share, quality, customer satisfaction. What we find is working in small batches, developing small feature increments, prototypes, pushing those out to production, getting feedback from real users, and then iterating rapidly to build things that deliver the outcomes you want for your users and your organization. Enabling teams to experiment. We're not throwing requirements over the wall to order-taking development teams. Development teams actually have input into what gets built. You have these highly trained, experienced professionals building software. They have ideas and opinions, and it's crazy not to leverage that.
Yeah.
So we find that those practices together positively impacts culture, performance, organizational performance. We've talked about culture a lot. I just want to quickly dive into how we measured culture. And again, Project Aristotle at Google, we confirmed some of the findings from that as well. We have this model of culture that comes from a sociologist called Ron Westrom. He's looking at safety outcomes in aviation and healthcare, so safety critical fields. And he has this typology where he divides organizations up as to whether they're pathological, power-oriented, bureaucratic, or generative, or mission or performance-oriented. And you can probably, if you're following along at home here, work out where you fit on this pretty easily. It's kind of quite a visceral model. And there's 6 different axes here that he looks at. The extent to which people cooperate between different parts of the organization. How do we deal with people who bring us bad news? Do we train people to bring us bad news so that we can act on it rapidly before something really bad happens?
Right.
Do we ignore people who bring us bad news, or do we, shoot the messenger and say, how dare you tell me this thing that I don't want anyone to know about?
Yeah.
How do we deal with responsibilities? Do we avoid them because we know we're going to get into trouble when things go wrong? Or do we believe that we succeed or fail as a team and share risks because we trust each other? How do we deal with bridging between different parts of the organization? And then 2 things that are really 2 different sides of the same coin, I think. How do we deal with failure and the extent to which we're able to innovate? So failure here, does that lead to blaming people? Melody,
right.
you messed this up, you're a terrible person. Or, we're building complex systems, failure is inevitable. Thank
That's
you for
right.
helping us find this problem that we can now do something about.
That's right.
And that's important if you're going to innovate. Innovate, by definition, is doing things that have never been done before. So there's a high risk of failure whenever you're innovating. If people are worried that they're going to get punished when things go wrong, they're not going to innovate.
Yeah.
So
go ahead.
No, please.
You bring up so many important points. I mean, humans, we're the ones writing the software, right? We're writing the code, we're operating the service. We have to trust each other, right? So I think DevOps has been extremely powerful in starting to break down those walls and take the practices and the tools and the automation behind it and really help to reinforce the trust between the individuals. Because this is software. It's not going to be perfect. There's going to be bugs, there's going to be issues. How we work together in those situations is such an important part of it.
Yeah, and our research backs up exactly what you said, which is that the way you impact culture is through implementing these practices, these technical practices, these management practices. So, a couple of things that we found this year in terms of impacting culture. We talked about the technical and management practices. We also found that retrospectives are really important. Retrospectives, learning reviews, postmortems, these kinds of activities impact culture positively. They also help create a climate for learning. A climate for learning is when organizations treat learning as an investment, as something that we should make sure people have the resources and time to be able to do, not some kind of afterthought, well, do your learning on the weekend so that you can, work the number of hours you're supposed to work in your time card. So what we find is that elite performers are 1.5 times more likely to consistently hold retrospectives and learning reviews, and also critically to use the outputs of those activities to improve their work.
Yeah, you bring up so many important points from the research. I just wanted to share, at Google, we see a lot of these principles in action, and I just wanted to highlight a couple of them. So the first part is, how do you take the personal out of it? Look at the data, look at the code, look at the logs, look at the dependencies, look at traces, understand error rates. Developers and operators come back to the data to guide those decisions. How can we learn the most that we possibly can about what's happening in the system to fix the problem? Having a shared fate and collaborating between developers and operators. So we shared an example today about air budgets and how developers and SREs work together around air budgets. Getting everyone oriented around what we're trying to do and why we're trying to do it is such an important part. It affects communication, it affects trust, and how we work together. Transparency, so everyone sees the same thing. We have tools in writing code, in running build and tests, in our code review that we highlighted a little bit today, that makes all that data visible. Right? So we're not withholding information or trying to control information in your cultural observations so that people can take action to resolve the issue as quickly as possible. And near and dear to my heart, blameless postmortems. My development team does them every week. We sit down, we learn, we talk about what happened, we understand what measures we took, We think about not just technical fixes, but process fixes. And we take away a set of to-dos that we hold ourselves accountable for. And again, like this is just reinforcing that we're going to take risks. We're going to do things that haven't been done before, but we're going to learn from it, right? We're all here to learn. We all make mistakes. Perfection is, as I said before, unrealistic. And we're building that trust between the developers and operators by doing that.
Yeah, and I just want to put in a quick plug for the Google SRE book and the Google SRE workbook that just came out last month, I believe. There's a lot of discussion about how you do those kinds of activities at Google, which is really great.
Absolutely.
So, open source. Obviously, open source is a big deal at Google. You contribute a lot. We found that actually only 58% of responders said they were using open source components, libraries, and platforms extensively. That was a surprise for me. I expected it to be more. And I wonder the extent to which people aren't considering all the layers in the stack. I mean, it's kind of inconceivable to me that anyone would not be using open source somewhere, whether it's in terms of the operating system, the libraries they're consuming, and the other pieces of the ecosystem, the infrastructure, and so forth.
Right.
But this is what the data says. 50% agreed that their team planned to expand use of open source software. And we find that it's correlated with high performance. Elite performers are 1.75 times more likely to make extensive use of open source components.
So at Google Cloud Platform, we're very committed to investing in open source. Google has one of the highest contribution rates to open source. We believe in the power and influence of open source. And you can see some examples here of recent open source contributions. Scaffold saw some issues that existed in the local build and test and deploy workflow, wanted to help influence and create solutions there. Kubernetes, we know that the adoption of containerized workflows is significantly increasing. Significant community there in terms of contributions. Istio and many others. When I talk to customers and developers and operators, there's such power in being able to contribute and influence how the open source product is evolving. And the community and power around that is so significant. For enterprise customers not wanting to be locked in, right? You've noticed this change in the last 5 to 10 years around and the acceptance of open source. And it's really exciting to see that.
Yeah, and you, Google Cloud Platform, you have a commitment to open source as well, right?
Yes, we do. We are committed to being the open cloud. And that doesn't just mean open source, it means open APIs and an open platform for developers and partners and customers to be able to collaborate together. So just to wrap up, we've shared a lot about Dora's latest research report on high-performing teams. There's an opportunity for us as software teams to use throughput and stability and availability to measure our performance. And we've seen the impact of that in the research that Jez shared today. DevOps, it matters whether it's commercial or non-commercial, right? So we're seeing with the advent of open source, we're seeing with enterprise goals that are being set, DevOps practices are starting to be employed more so than I think they ever have. Gave you an example of air budgets and tried to highlight how that common metric can help reinforce availability and a shared understanding of availability and how to have both feature velocity and stability and availability. And then with the right set of technical management and cultural practices can help DevOps, help create trust among the humans that are developing the software and increase velocity and business outcomes for those teams. So go ahead.
Yeah, I was just going to say, I mean, we've only scratched the surface of the report. If you want to go download it, you can go to bit.ly/2018-DevOps-report. I think we'll put the URL with the webcast as well. But I mean, there's a lot of material in there. We've just kind of highlighted some of the key points today.
There is. I have to go back and reread it another time. So thank you so much, Jez, for being here. Thank you so much for the research that you provided and for sharing this all with the DevOps community.
Thanks so much for having me.
Thank you. So stay tuned for the live Q&A. We'll be back in less than a minute. Thanks for coming back. We're here now to answer some live questions from the audience. I'm Melody and this is Jez. So let's just get into it.
Okay, so one question. Any nuggets of advice to give to someone carrying out an agile/DevOps transformation at a huge bank? So I hear this a lot, we're regulated, it's financial services, working in government or something, and it's hard. So I want to acknowledge, yes, it is hard. However, we do find in the research, and that's in the report this year, there is no difference, no statistically significant difference between verticals in terms of your ability to do this stuff. We find regulated organizations, large organizations, in the high-performing and the elite-performing groups. So you can do this. We've seen continuous delivery done with mainframes. So it's hard. I think the advice is probably don't do the whole organization at once. Find some part of the organization that you can practice on, that you can start learning, and then take the things that work and move them out through the organization. Accept that there's a bunch of things that won't work, and that's okay because you're learning as you go along. So my advice is go for it, but accept that it's going to be hard and it's going to take a bunch of time. Don't let that stop you from starting.
Yeah, absolutely. When I talk to financial institutions or institutions in healthcare, this question keeps coming up, and I think my advice would be similar to Jez. Start with a small piece, and really gain some momentum with that, because we know if you look out to open source, look at some of the research we've done, developers look to other developers for help and guidance. And when you have this success on maybe a particular area of your pipeline, if you start with CI/CD, it can go viral, and other developers will learn about it. They'll look to it as an example, and then they will help make it better. So start small, get some momentum going, and then you can really build from that, because the culture takes time to change. Right? We've seen that. It takes reinforcement of practices, takes development of tools, which takes time, and that shift between how the humans work together within whatever company it is that you're working at.
And I think huge organizations are very heterogeneous. You will typically find in a big organization that all the answers are there. Yeah. They're just scattered around in all different parts of the organization. So find the people who are doing the good stuff and find ways to spread that.
Right. Yeah, I've also advised internal hackathons and developer community events within financial institutions, where you bring the developers together to talk about the ideas that they have and some of the changes that they want to make.
Internal DevOps days, conferences.
Exactly. So can you talk a bit more about misguided performers? That was something the report mentioned.
Yes, and someone asked about outsourcing as well, and these kind of things are related. So when we did the cluster analysis, we found this group that is kind of similar to the low performers. They're releasing very infrequently, but their time to restore is really long. It's like multiple months to restore. And we kind of thought there must be something weird going on with, is the data right? We checked the data, that's what it told us.
Yeah.
And if you look in real life, you can see things like this happening. So, healthcare.gov was a good example where they got service somewhat restored quite in the space of days, but it took them months to actually fix all the systemic problems in the infrastructure and fully restore service to the level that was expected and required of that service. Security, vulnerabilities, if someone hacks into your system, it could easily take you months to pull all that out and fix all those problems, fix any data problems. When you think about it, that's real, and we see it reflected in the data. The message is, don't assume that going slowly is going to save you, because if you go very slowly and release very infrequently and think that you're going to prevent all the problems by doing all this very careful prevention work, that's going to hit you when something actually goes wrong, because it's going to really impact your ability to fix that rapidly. So that's what the data says. We also found a strong correlation between misguided performers and functional outsourcing. So people who are outsourcing either development or testing or ops, these individual functions, we find that elite performers almost never do that. Low performers do it much more often, and actually our misguided performers were the highest users of that kind of functional outsourcing.
Yeah, I think there's two things that makes me think of. The small batches, so how can you control the amount, waiting too long between releases, and having a fast iteration cycle that happens. We found that to be true at Google. And if we go back to this cycle of continuous improvement where we're trying to add in automation and insight, I could see how that outsourcing would be a challenge. Are people looking at the same data? Are they having access to make good decisions and exchange information between each other?
Can they even talk to each other and change the way they work and collaborate effectively?
Right. Interesting one we would probably both talk about, any ways in which one can drive cultural change for DevOps. Well, we've mentioned some of them. I think one of my principles to come back to within teams or where you run into obstacles is where does the trust start to break down? And I think having a strong culture that includes some of the principles that we shared with today, they really have to be lived. And you can come back to, at Google, we can use postmortems to look at where did things start to break down between the humans. Was there a piece of data that was missing? Did someone not have access to that information? Did we not have a common understanding around uptime, what uptime was? And how was the team not kind of coming to the outage or the issue that was coming up with all of that information in mind? So we all are responsible for upholding culture. And when we see it start to break down, we all have to raise our hand and say, what can we do better next time? How can we help each other and help build the trust back up?
Yeah, and you have disaster recovery testing exercises at Google.
Yeah, dirt testing. Yes, where we deliberately try and force things to go down to see where we might have gaps in our response and our practices. Thanks for bringing that up.
Yeah, no, I saw Kripa Krishnan talk about that in the past, and that was really interesting
amazing
stuff.
Yeah, great practices within SRE.
Okay, I think we're kind of out of time here pretty much.
Yeah, went by fast.
Yeah.
I know there are more questions. We will make sure they get responded to on the platform. I wanted to say thank you to everyone for coming today. Thank you so much to Jez and the team at Dora. Stay tuned for the next session, Advanced Serverless Data Processing in Cloud Data Flow. Thank you.